Paul will be discussing a big shift in battery storage, and that will be with supercapacitors. So, welcome, Paul.
Thanks, everyone. I'm Paul. So I'm here to talk to you today about a change in technology of how we store energy. Okay, so does anybody here use SP Pro inverters? Yeah, probably 20-30% of the people here know about them and use them, I'd say. Avio started developing technology around SP Pro inverters back in about 2014. We actually started programming in about 2011, and we developed technology to talk directly to SP Pro inverters to make them an Internet of Things device. So we did that about 4 years ago, and since then we developed programs that let you fully remotely program an SP Pro inverter from anywhere in the world without any IT skills. That's the kind of things we do. So we took the SP Pro inverter and we put it together with a charge controller. We found a charge controller manufacturer in Melbourne called iMark. Has anyone heard of iMark before? A few, not so many. Okay, iMark are in North Melbourne, small business, and they build charge controllers for the military. And they recently released this beautiful little charge controller here, which is 5 kilowatts with 2 MPPT inputs on it, up to 500 volts DC, with an Ethernet port on it. So we automatically thought, okay, it's got Ethernet, we can actually program this charge controller with our software and talk to the charge controller and the SP Pro inverter from one interface. It's a nice little machine. It's also available shortly in a 120 volt version with up to 8 MPPTs and 30 kilowatts of PV input. And it's only about 900 millimeters tall. So really good for DC coupled systems. Who does DC coupled here? Anybody? Yep. Okay, so you can do DC coupling with this Cellectronic inverter or AC coupling. You can learn about that from Cellectronic if you need to know more about that. We can do AC coupling with Fronius, obviously to the SP Pro, and we can get the data from that through our technology as well. So we can do a combination of AC and DC on an SP Pro. Remote access, this is our single board PC. It's called Emacs. You can come and see it at our stand. Single board 1.5 gigahertz processor computer with a Ethernet port on it and some USB ports. So we've been developing software on that board for about, in total about 6 years, and we released it to the trade about 1.5 years, 2 years ago, and we've got several hundred of them working in the field. It lets you do many things, so I'll show you what it can do. You can log into an SP Pro inverter from anywhere in the world without any IT skills, as I said before. You simply take the device, plug it into the USB on the bottom of the SP Pro inverter, give it some power, and plug it into an internet modem on site. Go home, type in your email address and password, and you can program it through SP-Link. So on the top left, you see it says connect to Emacs. Up here. You just connect to Emacs and off you go. You just put your email and password in. It lists all the inverters in the world that are associated with your email address as the installer. Here's a graph that you can get from it, an example. You can build all your own graphs as well. And we can pull data from all the metrics of all the SP Pro inverters on site. So a 3-phase system, 2-phase, 1-phase, etc. And you can do weeks and months of data. There's an app on your phone as well. You can come and see that at the stand. Chemical batteries, who uses chemical batteries here? Okay, a lot of people. So there's lots of different chemical batteries. There's lead acid, lithium ion, zinc bromide. There's probably other ones I don't know about yet. They all have this one fundamental problem, is that they have an age limit on them. They're designed to do a certain number of cycles, and you have to calculate that into your cost economics. The way we do that is we look at what we call cost per kilowatt hour life, which is just here. So typically it's about 15 cents. Some are 12 cents, some are 18 cents. So that's the round trip cost of an energy unit going into the product and coming back out again, and how much money you paid for it. Can you work out how that can be calculated? Basically, it's the unit cost of energy into that battery. Supercapacitor modules. So about a year ago, we were trying to work out how to make the ultimate off-grid, on-grid system. We'd already developed the software. We'd already partnered with Cellectronic to get the software to work really well, and iMark to get a DC coupled system. And so we took a supercapacitor manufacturer in Dubai, and we worked with them to bring this to market. Basically inside this module there's about 1,200 supercapacitor cells. I think I've got one here in my pocket to show you if you're interested. You can pass that around if you like. You want to pass that around? That's a cell. So that's full of graphene. Who knows what graphene is? Anybody? Yep. So graphene is enriched from graphite, and graphite is halfway between coal and diamond. So it's just compressed carbon. So the enriched graphite is laid on the cell of the capacitor, and it's wound, and it can hold energy. The electrode inside the capacitor is lithium ion, but it doesn't perform a charge and storage function. It performs a charge retention circuit function. That's another question for off the stand here. So the cell itself can be charged as little as 2 minutes. I've charged it to 4 minutes, and I'll show you a video on that soon. And the cells are designed for 45 years of working life. We haven't tested it that long yet, but capacitors are typically designed to do about 1 million charge cycles. So the cost per kilowatt hour life is 0.015 cents if you divide it by 1 million, but obviously you can't do that many cycles because it's just too far out. So depending on how many discharges and recharges you do per day and how many years you want to forecast out, the cost might be 1 cent or 2 per kilowatt hour life. So it's much less expensive than a chemical battery. This is the new module which we've got on the stand as well, which we've integrated a circuit breaker into the front of here. So it's a 300 amp circuit breaker, which is made by a company in Lesotho, which is in the middle of South Africa. It's an English Commonwealth Games country. I saw on the Commonwealth Games the other day. I didn't know that. So they make circuit breakers, and we worked with them to integrate the 300 amp motorized circuit breaker into the front of the unit, and that let us control the energy storage device remotely. So from a commissioning point of view, we can log in to a site away from here and turn off a supercapacitor remotely. So if you have, say, 10 of them in parallel and one of them sends an email to you and says this is out of voltage or out of current or something, we could just turn that one off and the system keeps running. So it's quite useful. It's got a very low internal resistance, which means it has a very high risk of energy. If you dropped a spanner across the terminals and you didn't have any circuit breaker in there, the energy release is so high that it could just about vaporize a piece of metal. So the circuit breaker helps us protect against that. It also helps us commission it remotely and allow us to bring up the capacitors to the same voltage before we parallel them. So if you had, say, 10 capacitors banks in parallel and you wanted to commission the system, they should all be about the same voltage before you parallel them. So using our software, we're able to turn on the lowest bank and charge it till it matches the highest bank voltage, and then keep turning that one off and then turn the next one on, so we can basically automatically commission the system without having to worry about user error. If you accidentally tried to parallel them and they weren't at the same voltage, the circuit breaker would trip. This is the unit being turned on. You see the circuit breaker on the right. The circuit breaker turned itself on, which means the terminal's alive. If you turn it off, the circuit breaker goes off. So it's very safe to transport. We can also do an anti-theft version. This is a fire test we did to see what happens if you burn a lithium-ion battery with a blowtorch. Don't recommend you try this at home. And then the supercapacitor cell is not flammable. So the electrolyte inside the supercapacitor cell is fully absorbed into the graphene matrix, so it's actually dry, and it only burns if you hold a flame to it. So it's a lot safer, in my opinion, to put into a residential building or anywhere really. This takes a little while, so you have to watch it patiently. So you see it'll start venting soon when it bursts open. And it's venting because it's so hot, it's hitting probably close to 1,000 degrees, and the electrolyte's evaporating and coming out, and it's burning in the flame, and it just self-extinguishes. So if you take the flame away, it puts itself out. So you can imagine if you got 1,200 of these cells in a pack and a house caught fire, a bushfire or something, the battery's not going to increase the fire or encourage the fire. So the next video, we'll put a few tests together just to show you what we've been doing to see how well it works. It's a bit monotonous, I know. Here we go. This is a fast charge test, so we put a cell on a high-powered DC power supply to bring it from 0 volts to 2.7 volts. The formula is basically when you want to charge it really fast, for every 0.5 volts you increase it above its nominal voltage, you can charge it 20 amps. So in this case I've gone from 2.7 to 3.2, which is 0.5 volts, so I'm able to charge at 20 amps. So that power supply is able to deliver up to 90 amps. So turning it on here, it quickly jumps up to about 40 amps at the bottom here, and then pulls back to about 30, and then falls away to 20. And I think it goes to fast forward mode in a minute. And you'll see that it gets all the way to full in about 3.5 minutes. So you can imagine, we don't recommend you charge them this fast because they get a bit warm. They hit about 65 degrees Celsius at that rate. But if you're charging them in half an hour, that's, compared to 4 minutes, it's far less. So we've done cycle testing on the cells as a module, and we've done cycle testing for about 3 or 4 months with a 50-minute charge cycle. So 50 minutes to full and empty on the entire pack. And the pack got to about 40 degrees Celsius and just sat there. And we had a round trip efficiency of about 2% loss in each direction. So the loss of energy when you're charging it at full power continuously for 3 months on end loses very, very little energy at all, which means the pack doesn't get hot, which means you get a better outcome. There's some data from the test. This is a new cell which we're going to release probably in about 6 months, which is the world's first non-disposable battery. You can pass that one around if you'd like to, sir. Oh, sorry. It's basically a USB chargeable supercapacitor. So you plug it into your computer, and then you see on the video how it works. So at the moment, I believe Australians throw out 86 million tonnes of batteries into a landfill per year. I've heard something ridiculous number like that. No, it's a lot of batteries. I'm not sure the statistic exactly, but in this case, you don't have to throw the batteries away anymore, which is much better for the environment. The battery is mostly made of graphene, which is coal anyway, carbon, or coal carbon. And hopefully the world can stop wasting batteries. This is the circuit breaker we use inside the supercapacitor module to provide the safety. So it's a short circuit test. So it's currently set across the terminals of the supercapacitor, and it's a dead short. You can see the arc fly at the top of the circuit breaker. So that's built into the unit to give us protection. This is the module here on the desk, which is a 12 or 24 volt battery. You're going to pass that one around to somebody? David or someone? Oh, you can't grab it. So that weighs 8.1 kilograms. And if you open the little blue lid on it, you can press the button and it tells you the voltage. That's a 24 volt cell. So that'll do 800 cold cranking amps. Who knows what cold cranking amps is? Yep. Okay, so basically it's how much grunt it can give you to run a vehicle when you're starting it. They've actually built a small pack which is the size of your fist, which will start a V8 engine. That's how powerful the capacitors are, because they can discharge so quickly. This is the forklift we enabled with the supercapacitor module. It enabled us to run the forklift at full power. And here's an example of charging it at high rates. That's at 70 amps. And the temperature's only 26, 27 degrees. So there's some videos. We've got lots more videos if you want to see more at the show, at the stand. So basically a supercapacitor is an electrochemical capacitor in most cases. There are many different versions. There's not like one type. It's like saying this is a lithium-ion battery. There's probably 20 or 30 different varieties of lithium-ion batteries. Effectively, the way the capacitors work, which is different to electrochemical batteries, is they use an enormous surface area to store energy electrostatically. That's different to a chemical battery. The energy stored on the surface of graphene in this case, which is the material that's enriched from graphite. The surface area in each cell is about 4 acres. And that's the cell you're passing around, which is about 16,000 square meters for those who like metric. And so each pack has got 4,800 acres, which is a very, very big farm. You can imagine when you rub your hand on a balloon and you get a static shock, the surface area is holding the energy. In this case, it's being stored on a very messy carbon compound. Currently, the cells are at 115 watt hours per kilogram, but the theoretical capacity is up to 350 watt hours per kilogram. So in the not too distant future, we'll have much larger capacity packs. If you look at supercapacitors compared to other types of technology, you see electrolytic capacitors are over here, fuel cells are over here, lithium-ion batteries are in here, other new things coming on here, and supercapacitors are up here. They have very high power and very good energy density. and the future's way up here somewhere. Kilowatt Labs is the manufacturer of the pack that we use, and we're working with them to embed our code inside their product to allow us to merge it with all the other technologies and bring out different module sizes. So the one you saw in the picture is just one version. We can build any voltage pack that you want. So you might have a particular need for a 120 volt pack or a 384 volt pack. We can go up to 1000 volts per pack, and almost any number of cells in parallel. The temperature operating range is up to 85 degrees at the cell level, but we recommend you design around keeping it above -10 and below 55 degrees just to get the best life out of the electronics. And it's a 10-year warranty with unlimited cycles. You can charge in 30 minutes. It's 99% round trip efficiency at the cell level and 96% tested at the terminals. That's our own independent testing, was by charging and discharging 14 times for an entire day and looking at the average loss, not looking at the best case, it's the average loss. Very high cycle life, very high efficiency. It's good for off-grid, good for on-grid. There's about 800 of them going at the moment into South Africa and Zimbabwe, into mobile phone towers. One of the reasons they're attractive for mobile phone towers is that you can be sure that if somebody steals it, it won't work because of the anti-theft function. So if somebody steals it, takes it off the system, puts it back on again, it won't come on unless we send it a command. You don't have to have the anti-theft function if you don't want it, but it's a nice feature for that area of the world. Because when they steal batteries there, they steal them at gunpoint. And if they steal a lead battery, they can melt it down for lead. If they steal a supercapacitor, there's no raw material value in it. So they're safer. You see that by the fire test. They work in a larger operating band. They have a higher round trip efficiency than most chemical batteries. And they have a design life of 1 million cycles. We haven't tested it that long, obviously, but knowing it can go out that far, it gives you a lot of reassurance, so you don't have to worry about the typical 10 or 20,000 cycles you might experience over 10 or 20 years. Here's a comparison of different technologies: lithium-ion, lead-acid, flow, and Sirius supercapacitor module. You can see here that we're at 1 million cycles, 99% efficiency at the capacitor level. Depth of discharge is 100%. You can take it to 0 and it doesn't wreck it. You just recharge it again. And there's almost no current limit. So that pack you saw before is a 3.55 kilowatt hour module, and it can peak at about 15 kilowatts DC before the circuit breaker trips. I've actually peaked it at about 23 kilowatts for short bursts, so it's very powerful. And typically, it's no longer the battery that's the limit, it's now the inverter, which is a great place to be from a design point of view. So you don't design around peaking power anymore, you design around kilowatt hours. So if you have a requirement for 10 kilowatt hours, it's 3.5 kilowatt hour pack, you take 10 divided by 3.5 and you need 3 batteries, that's it. You don't have to think about peaking power or temperature or anything, you just put them in parallel. This is the cabinet we put together. We called it the Independence Day system because it's the day that you can become independent if you want to. Glenn was speaking earlier about staying on the grid or sliding off the grid. This lets you do that. So this inverter, this electronic inverter, is a great inverter. It allows you to be on grid, off grid with a generator, on grid with a generator and the grid as an option, and it gives you really high peaking power. So it can peak at about 18,000 watts for 30 seconds AC, which is more than most houses' main switchboards need. And when you combine it with supercapacitor modules that can peak at such high current limits, you can really go off grid properly. It just comes down to kilowatt hours of storage. And if you have a generator as your final mile, then you can have an auto start generator that will be started by the inverter detecting the battery getting to a low state of charge, or you could have a manual generator and the software can send you an SMS to say go and pull the LD generator you bought on special and run it for 2 hours. So you can do a manual start generator or an auto start generator. This is a system that Marty and Adele put together, which is the biggest one we've done so far. It's a full 3-phase system. So the Emacs product I talked about earlier with a remote access protocol in it lets us plug into 3 SP Pros and do full remote monitoring of the system. This one's now live in Warrandyte in Melbourne, and it's got 3 7.1 kilowatt hour supercapacitor modules in parallel, giving us 21.3 kilowatt hours of total storage, and peaking power off this chart. So that'll peak at around about, the inverters are the limit basically. You can't draw enough power from them to cause any damage. That's the cabinet there installed. So 3 modules there, fully monitored. You've got here 3 SP Pro inverters, 3 charge controllers, 15 kilowatts of solar panels on the roof, there's sun power. Got here a switchboard which brings all this stuff together. We call this the AC cabinet, where we've put all the AC together. We call this a DC cabinet, where we've got a big mother of a DC circuit breaker here that's 630 amps with a fault current rating of about 80 kA, I think it is. We've got small switches here to control the thermofan. So the DC charge controller controls the thermofan. So if it detects a cabin temperature of above 45 degrees, it turns the fan on until the temperature falls to 35 degrees. And you can set that up in the iMark charge controller. You can set the start and stop points for the fan. And this is the same charge controller that you can get as a 120 volt version. And over here we call this the data cabinet. So it's everything the same in all cabinets, but this one's got the Ethernet switch here, which picks up the Ethernet data from the supercapacitors, the Ethernet from the charge controllers, and the USB from the SP Pro inverters comes back to the Emacs over here, which is the device that does the remote access reporting. I'm not sure if Electronic have released it officially yet, but this is probably one of the first systems where we've used the new comms boards in the SP Pro inverters. So actually, we don't have a USB cable to each of the 3 inverters like we used to do. We just talk to the first one, and the first one gathers the data from the other 2 automatically. So now you can program this SP Pro as a single inverter, and you tell it it's 3-phase, and it finds the other 2 inverters on the bus, and you don't have to log into those 2 and program them as well. So it's quite useful in that way. So within about a week of them releasing that new protocol beta version, we updated our Emacs to be able to cooperate with that as well. The delivery of the first supercapacitor cells in Australia is coming in April, so they're due at the end of the month. They're already pretty well sold out, and there's more coming every month. So we've got pre-orders for several hundred so far, and a lot of the systems they're going out through system integrators primarily. We're not trying to retail them to our end users. We really are looking to work with supercapacitor-minded system integrators. So yeah, would you like me to talk more or do question time? Or okay, does anyone have any questions?
Yep.
We've got a roving microphone somewhere? Just behind you, this one. Oh, okay.
Wow, that's pretty cool. Is there an upper kilowatt hour limit in terms of, I guess, parallel strings and everything else? Usually technologies do have that, and I think all of the costs were in kilowatt hours over a lifetime, so just an indication of price per kilowatt hour rated for a single usage.
It's only available to trade. We don't sell to retail, so it's $1 per watt hour.
$1 per watt hour.
Yeah, that's just in small quantities. In larger quantities like pellets and shipping containers, you can get a better price as well. What's the other question?
Just about if there's any limit to how big a system can go. We saw sort of numbers around 10 and 21, but if somebody wanted 100 kilowatt hours of this technology, could they do it?
Yeah, it's unlimited parallel. You just got to watch out for safety.
Yep.
Yeah, because your fault current gets pretty high.
And what's the largest you get out of a single string? Because I think at the moment it's what, about a 2-volt cell, and how many kilowatt hours for a 2 volt?
No, they're 48 volt packs.
Oh, the packs are, okay.
Yeah. So 48 volt packs, and they will give you 3.55 kilowatt hours of storage, and they operate between 54 and 44 volts DC. But if you had a specific requirement for a particular voltage, like Electronic makes a 120 volt inverter as well, we're looking to bring out a 144 volt pack soon, which works really well with that inverter and that charge controller. And somebody else recently asked for a 384 volt pack. So we just changed the series parallel configuration internally to get the different voltage outcome. But when you go past certain voltage, we start dealing with safety questions, which when you go past 60 volts, you've got different safety requirements.
So what's the largest amount of strings you put in parallel, and does it have those sort of issues surrounding?
There's not really an upper limit. It's 1,000 volts DC is the maximum voltage we can do. Yeah. And then we just work out how much energy you need and how heavy you want the pack to be. It's got to be manageable. You've got to be able to lift it up and put it into a cabinet or something. So you could make a 384 volt pack, which with 5 kilowatt hours, for example.
I just meant staying at 48 volts. Yeah.
Oh, the biggest pack we have available at the moment is 7.1 kilowatt hours at 48 volts.
Yeah.
That's off the shelf. Yeah, okay. Thank you.
Does it have to conform to battery standards, or did we waste our time doing this new standard?
No, I think it's good because the standard doesn't just cover, although it talks about electrochemical batteries a lot, the new draft standards actually talks about a battery as a device which stores energy. So effectively that's a battery in that mindset. If you look at the draft standards, it talks about energy, voltage, the physical battery, the weight, and the chemical risk. So yes, we have a weight risk. You could drop it on your foot, so we have to consider that in our design. We have an energy risk because it has a very high fault current, but we put a circuit breaker in to deal with that, so it's a lot less risky. Whereas some batteries don't have circuit breakers integrated, like a lead battery, for example. You could put 24 lead batteries together and your fault current's enormous before you put a circuit breaker on, and those terminals are accessible to somebody. Whereas having the circuit breaker inside reduces the energy risk. There's no chemical risk, as you saw the fire test there. We can ship them by plane as well, which is quite useful. A lot of areas you can't ship lithium-ion batteries by plane. I think the limit is 160 watt hours to ship a lithium-ion battery by airplane. We ship these by airplane in from Dubai. So the aircrafts are happy with it, so we're happy with it.
Just a quick one in terms of transport. Do you transport them fully discharged or?
We can transport them charged or discharged, because there's no energy risk if the circuit breaker's off.
Yeah, I was thinking about if you transport them by road or whatever and there's a crash.
Okay.
Thinking about the issue with lithium-ion batteries and aeroplanes and they get really upset.
There's no thermal runaway risk.
No, I appreciate that.
Yeah.
No, it's mechanical risk I'm thinking to the battery.
You could transport them fully charged. I guess there's a risk there. We have had one of them get dropped out of a plane's cargo hold door onto the tarmac, and it wrecked it, but it just fizzed. It didn't actually catch on fire or anything. So as far as crash testing, no, we haven't done any crash testing yet as to what would happen in the event of a crash. But the energy, there's no thermal runaway. So if you short the cell out, it'll just waste all its energy really quickly. So the short circuit, I've done a short circuit current test on the cell, if that might be a good way to answer the question. We dead shorted the cell with a copper bar and just ran it to zero. It actually damaged the cell a bit because it was so fast to discharge. It discharged in about 15 seconds. But the cell emptied all its energy in one go. It got hot and then it cooled off again.
Okay, just continuing on there. If you transport it by air,
Yes.
what do you declare it as?
A supercapacitor module.
And the airlines know what that means, do they?
We've got an MSDS,
Okay.
which was written in conjunction with the airlines.
Okay, that's fine. So if it satisfies that, it should satisfy road transport rules as well.
It should, yeah, but we always think a bit beyond the rules because the standards are really only there to help us make good decisions. Yeah. Another question? Hello.
Does it have any role to play auxiliary benefit to the power factor correction at a customer side, because it is a capacitor bank essentially?
Well, not by itself, but in conjunction with this electronic inverter, it could do that. So we've written some software. Who knows about FCAS here? Anybody? It's frequency controlled ancillary service. It's where you basically become a market participant to help stabilize the grid. So the grid has a 50 hertz nominal rate. If the frequency falls below 49.85 hertz, then AMO wants you to do something about bringing it back to 50 hertz again. If it goes over 50.15 hertz, then they want you to do something to pull it back again. So there's a market segment where you can become a participant, and your device can be programmed to inject power or draw power from the grid to stabilize the grid, and you get paid a lot of money for it. It's a ridiculous amount of money. We worked out that if we built a shipping containerized system here using supercapacitor modules, the payback was under a year. So basically, by all the money you get from AMO for doing FCAS market support, by pushing and pulling energy from the grid, the recovery on the actual investment is less than a year. So in answer to your question about power factor correction, the SP Pro can do power factor correction, and our software can actually power factor correct by telling the SP Pro to do certain things. So it's possible, but you probably need to explain your application to us offline and we can see what we can do.
Can you only DC couple it?
You can DC couple and AC couple. You can do both or either.
So the electronic charging is quite adequate for it. There's no issue.
Yes.
But you speak up a little bit, please.
So the question was, can you DC couple or AC couple? Yeah, you can. So with the 7.5 kilowatt hour SP Pro, the SPMC482, you can tell that to charge from the grid up to about 9 kilowatts and discharge to the grid at about 9 kilowatts. That's the limit of it. It's about 20% above its nameplate. And we have done charging. In fact, all our cycle testing was using the grid as a source. So we basically charge from the grid the highest power we can get from the inverter, and then we discharge to the grid at the highest power it'll give us, and we cycle tested that with a sawtooth data charge over a long period. So yes, it can AC couple and it can DC couple.
So you have a preference for DC couple there and those with those electronic units?
The reason I like DC coupling is because it gets past as AS4777.2. So the inverter standard came out, and one of the rules in there, I don't know which page it is, it's page 12 or something from memory, but they basically say an inverter is a device that converts DC to AC. So if you do an AC coupled system where you take an SP Pro inverter and you put a Fronius inverter beside it, some distributors, for example AusNet in Melbourne, they say you have 2 inverters there. We're going to add up the inverters on that phase, 7.5 kilowatts from the SP Pro, 8 kilowatts from the Fronius, there's 15 kilowatts, you're way over the limit, you can't have that. If you do a DC coupled system, they've only got 1 inverter to count. So that's why DC coupling is really good. But also, there's a limit to AC couple where it's, with SP Pro, it's 2 times the nameplate rating of the inverter. So the SP MC482 can go from 7.5 kilowatts continuous. The AC coupling limit's 15 kilowatts. What if you want more? You can't do it. DC coupling, there's no upper limit because you're storing the energy straight in the capacitor bank. So you can have a large disproportionate size between your AC inverter and your DC charging from your panel. So you have a very big PV system with a tiny AC inverter if that's what suits your application. But there is no wrong and right, it just depends on which sort of job you're doing. It works with both really well, and the Emacs plots the production data of the shunt, or the charge controller, or the Fronius all separately, so you can see how much power you're making from each PV source. Thanks.
So you look like you have the ability to keep tweaking your software to update your system as a customer or an installer.
Yes.
With your little computer pack that you talk about, where I can interrogate.
Yep.
How does that get updated?
Okay, so we can do batch upgrades. So the firmware that sits inside the Emacs is accessible to us as the manufacturer of the software. And we've done batch upgrades before. We've released a new version. We just send it out to all the products and they'll update automatically. You can also do a firmware upgrade of the SP Pro inverter by logging in through SP-Link, going to firmware upgrade, and you can upgrade that remotely as well. And there's 5 different services we run to keep the system alive. So if there's some reason the port was blocked or there was a fault with some part of the internet, we can get through 5 different ways to that product to maintain it. So it's got SSL certificates for protection, just like your internet banking app has. So it's fairly highly secure. We have a database that sits in the back end that runs on a 50 megabit fiber. So all the data is cached off site all the time. If the internet's lost on that device for some reason, say for example a houseboat floating out of range, when it comes back into range it recaches all the data again. And the device itself holds up to 10 years of history. So it's a pretty powerful little device, and it's very easy for installers to implement it without any IT skills.
In the front here.
Yeah, you seem to have quite a preference for this electronic. Are there any limitations, say if you're using just Fronius or Victron or any other?
No, there's no limit. It's a battery in the eyes of another inverter.
Okay, so it's just what you prefer to use electronic in most of your systems?
No, we like it because it is really good for all applications, and we don't have to discuss it with anybody. Most other inverters, there's a limit somewhere, and you've got to say, oh, you can do all that, but not that. SP Pro, you just say, it does everything, don't ask.
Okay.
So for me, it's easier.
Don't ask questions.
But it works with Victron, it works with Solux, it works with all those inverters. You just have to set the voltage window to match the capacitor voltage charging window.
Yeah, and that'd be the critical thing, it'd be to choose equipment that you can actually select that window.
Yeah, exactly right.
Yeah.
You've just got to check that the inverter will let you work in that window, which most do. I can't see why they wouldn't because it's a LED window. Yeah. Do you have any more questions? Yeah, down the front here? Just wait for the microphone so I can hear.
Hello. In off-grid system, we deal with a lot of small discharge and small charge current. Is that sort of degrading the capacitor?
No, not at all. No. The question was, does it matter if it charges at a low rate or discharges at a low rate? No, it doesn't matter. It works at any charge rate. So it doesn't matter if it's high power, low power, high energy, low energy. It works perfectly well. It's actually more efficient at low power. So the 96% round trip efficiency was at full nameplate rating. If you back it off, it's even more efficient. But you're splitting hairs from 2% loss per direction to 1% loss per direction. It's not really worth talking about. Better to put more solar panels on. Yeah, thank you.
I've got a question. In relation to the lithium ion that you've got in there, what's the role of that, and what's the relationship of the 40-year life relative to the lithium ion component, and what's the role in what's the process in replacing that lithium ion component?
Well, lithium ion's actually embedded in the capacitor.
Is it? Okay.
Yeah, so you can't replace it. It doesn't really perform a charge energy storage function. It's a charge retention circuit.
Okay.
So it almost does no work except if you take it off charge. So it doesn't really age or cause degradation of the cell.
So it is a part of self-discharge control?
It prevents self-discharge, exactly right.
Yeah, okay.
So normally a capacitor would self-discharge in a couple of days. Some better ones might last a week. These ones can self-discharge as a pack using the electronics. They're about 2% per month. So it's a very big jump.
Yeah, similar to lead acid, yeah.
Yeah, it is similar to lead acid, yeah.
Okay.
And if you discharge it to zero, you just recharge it again. So you don't have to worry about accidentally. They're apprentice proof. The apprentice programs the inverter wrong and you discharge your batteries to 0 volts. In some cases that really wrecks the batteries, in this case it doesn't, so you just recharge them again. Yes, sir?
You were saying yesterday that your higher voltage window is a fair bit lower than what we would normally set SP Pros to for lead acids or lithium ion. With most capacitors I've worked with over the years, why can't we go those few volts higher? What's the limitation there?
It's just the way that particular pack is designed. If you want a higher voltage pack, you might want to say, because it's 2.7 volt increments, so you might say my inverter works better between 50 and 60 volts. So we could make a 22 cell in series pack, which would add 5.4 volts to the 54 volts, so it's 59.4 volt pack nominal, and then it'll operate in the sweet spot for the SP Pro. Most of the energy is delivered from 54 down to about 47 volts anyway. An SP Pro doesn't really mind much below about 48 anyway, so it's kind of splitting hairs again, yeah. But we can make a pack that suits you if you need it. You just have to buy 1,000 of them at once.
Yeah, g'day. In the rural areas in WA, I can imagine a lot of farms would be kind of interested in this as well. We have a lot of two-phase in WA.
Yes.
So I'm thinking 2 of those.
2 SP
cabinets.
Pros, yes.
Yep.
Yep.
What sort of panel capacity could I have in two-phase in those 7.3s?
Well, it's unlimited because it's just how many charge controllers you add. So if you have that, as you saw in the picture, with 2 charge controllers, that'll take about 6 kilowatts of panels per charge controller. If you have 2 cabinets, you've got 12 kilowatts of panels on the standard solution, and that's on a DC bus that's shared across both phases. So if you draw more from phase 1, it doesn't matter that you had generation on phase 2. It's a common DC bus. And so it's synchronized with a sync cable, so they're 180 degrees apart in the case of a swirl line, for example. So one inverter is 180 degrees forward of the other, and the sync cable manages that. So then if you have a power failure, then the inverter will automatically open the contactors up, and all the DC power is available to both inverters to produce the AC power for the load. And if you want to add more PV onto it, you can add an AC coupled inverter, Fronius or ABB. That's the best way to do it, or you can add another charge controller. So you really can just keep going until you've set it as much generation as you want, and you can keep going on the supercapacitor packs to as much storage as you want. There's no upper limit there, within reason.